Hi, everyone. Welcome to the working group serving workstream autoscaling. This meeting is being recorded and we follow the CNCF protocol for meetings. So please behave and be nice with each other. So hi, everyone. As we left on the last meeting, we said that this meeting we will be kind of like brainstorming on caching and startup times ways for optimization, right? It was kind of like left open. So everyone, if you have access to the document, please jump in. But just as a reminder, we set it as next week, just a brainstorm on workload startup improvements or also model caching. Knowing that if you have model cache, you can enhance your startup time. So like both are tied together. So is anyone that wants to kind of like start the conversation, raise the hand.
Oddly, I don't have the raise hand button on my Zoom in this meeting.
Yeah, I was going to count going once, going twice, but yeah, if not that we start talking, but I want to open the room if
Yeah,
someone has ideas. Yeah.
yeah, I can start and chat and discuss this a little bit. As we have at Octo.ai, we have done a number of things in this regard. I think the top of mind for me is like first off the base container images and the images like the Docker image aspect of model inference hosting. The containers images tend to be quite large, so we're talking. I mean, even NVIDIA's base images are several gigabytes, but then you build on top of that and you end up with 5, 10, 15, 20 gigabyte Docker container images are not too surprising to come across in Gen AI. And then you've got obviously the model weights and how you move the model weights around and how you get those loaded into the GPUs efficiently. So those are sort of like two of the major areas. The other ones are like with regards to auto scaling and routing. Let's say we're talking about custom checkpoints or fine tune or even LoRa's and routing traffic to the nodes that we know have already have that data locally or already have that data loaded in the GPUs. Um, those are sort of the key things there. For us, we achieve the best performance currently on the cloud providers using highly parallel, like we have basically have a sidecar container that inits our inference that uses parallel reads from cloud storage buckets like GCS on Google and S3 on AWS. And we get over 40 gigabit per second on both of those.
How about the restarts of the inference part then? Does this sidecar every time pull fresh from the GCS or the storage
Um,
to the host?
Pod restarts I have to look at that. I think we may have done some optimizations where there's some local storage of that data, but it might be pulling it again if
Yeah.
insert.
Yeah, one of the things that here we were actually looking at is that we're hypothesizing that model weights themselves are not changing that frequently for inference use case compared with like say fine tuning like LoRa adapters or the inference optimizations. So if we were considering like would we be able to leverage the layering of images so that we can get the caching on the host when you have restarts, you don't really are not changing your weights. And so if you're building your inference image using weights as an image and your inference server as a separate image, then you don't really have, then container D would do that caching for you on the host. On restarts, you could gain a faster, you basically don't have to pull weights every time.
Right.
Weights are
I think that one of the yeah, and there's some technologies there that you can leverage and that are available on the clouds, like streaming technologies and other things, so that you can have Docker images that actually mount directly into a file system and then can also stream. So there's Dragonfly and Nidus it's called. Have you heard of that? So this is from, I think it's from ByteDance, actually. I don't know if they're on the call, but Nidus is an image format that also leverages the enhanced read-only file system, EROFS, which is like a Linux file system that was developed for mobile devices, but it's a read-only high-performance file system that allows sort of like high performance streaming of Docker images. And so there's this whole this whole like other area of things, because one of the problems with having weights data in your Docker images is that Docker images are single threaded. It's gzip compressed generally, where it's like the compression is single threaded decompression and such. So you have that aspect of it when you pull those images, at least initially, like of decompressing them.
I wanted to add actually too, like one of the other advantages of images is just all of the other infrastructure around it: scanning, authorization, features in Kubernetes, existing auth, et cetera, et cetera, et cetera. So I think this is actually one where I think I've been looking for feedback from, I think like any feedback that we could get from people who've deployed. It's easy to do GCS or S3 or Minio or download a URL. But just because something's easy doesn't mean that that's the, from a platform. I think about this like as two people sit down and throw together a workflow, and then someone later on comes and adds 3 more layers to it and starts adding requirements. I think from a platform team perspective, if I was a platform team, depending on your sophistication, some of them are going to be like, hey, this is just artifact distribution. Why do we have 2 different systems for artifact distribution? I feel like that core tension, I don't have a clear intuition from people in the ecosystem, from users, which ones they prefer. It's almost, I've heard inference platform teams say, we prefer to use container images. There's it's a little heavy and a little annoying today. And then I've also heard people be like, and I don't want to throw shade, ML engineers be like, I don't care about Docker images. And I think that tension, there are disadvantages to images. And so until those are mitigated, maybe like Jeff, like his good way of framing is, until we've mitigated the downsides of images, we can't expect anyone except platform teams to adopt it. But at the end, we want people to be like, yeah, this is just easier. Why am I doing all this complex work?
Yeah.
I have to get a container anyway. Like I'm not crazy. I'm not gonna be running in production with like random stuff downloaded from the internet. Oh wait, I am. But I think like some of those factors, I've been looking for guidance. I think the working groups could use a lot of guidance from people who've gone down there. If you've got strong opinions.
So I share that, like on our side, our ML engineers are all about images, like Docker images, like they live and breathe that stuff. They're happy with it, but there's problems with the aforementioned problems with like the OCI spec has problems. The OCI spec doesn't allow, so like for the registry spec doesn't allow parallel uploads of layers, for example. So like there's little things there, the little performance things.
So I've heard people say this, the OCI spec may not, the original Docker v2 distribution implementation did.
Interesting.
So this is, maybe I'm misremembering, although I helped draft the original Docker distribution spec because the original one was terrible. But I know like in the early days, a lot of parallel optimizations were made on upload.
You can upload multiple layers in parallel, but like a single layer uploading Yeah, is
Got
linear. Yeah.
Got it. Yeah, that's definitely a problem. Sorry.
Yeah.
Yeah, I wanted to comment on that. Clayton, is a conversation we are having also is we have OCI, we have like a secondary protocol that is the ORAS one, right? Like the OCI artifacts kind of like protocol. But I've been jumping into many conversations where people say like, oh, should we have like a OCI image spec for pulling things from Hugging Face? And then the conversations start going into more standards into pulling and goes back to this conversation, right? Like, should we all standardize on S3? And I've started hearing so many protocols from moving the models around. And I'm like, we have OCI, like we have so many APIs and code written on like pulling and pushing containers that can we just make it easier for handling modules in containers? Or do we really need a, a protocol for this?
So, and I just want to add this because it's really important. Mernal is not here, and he and I were chatting about that same problem. Like we're kind of like OCI. Like, why do we need OCI artifacts? Why don't we just improve OCI images? And Sam Karp actually from the Google side, he helps like do a lot of the upstream OCI stuff. Works in Containerd. Like he and I were just having a conversation about this. Oh, sorry. Maybe mute, unmute. But I think there is an appetite to just improve OCI images. Is this the group that's going to help push it over the edge? Because we want weights. We want to go solve these problems because they'll help everybody. Can we justify it? Sorry for jumping in line.
We have two raised hands, but I can see the order. I think Kunjan, you're first according to this. Yeah, you're first.
Okay. Yeah, actually, I personally tried both approaches with the OCI artifact and just having an image, weights in the image. I found the tooling with OCI artifacts is not that commonplace, especially also when it comes to cloud repositories and like for building and pulling. It's not, well, Containerd for one doesn't support it, right? And so I think I'm more on the side of like improving the image itself. And I do like the idea of standardizing pulling from Hugging Face, because that's one of the, with this approach, my key gripe was that building that initial weights into an image was my initial problem, especially what Jeff said about parallel pushing. It would my build pipeline for creating packaging weights into images was too long because of especially the push from my local to the repository, because the image is huge. But on the consuming side, I did think that there is some benefits when it comes to life cycles. For example, there's some sidecar or CSI drivers that you can use to mount storage buckets as volumes. Those, I find like the life cycle of those are mapped to the pod life cycle, so you lose a lot. You would have to go around that to get local caching working, which with this, I think we get a lot of those benefits out of the box.
Shenjin, you're next.
Right. I just have some questions on the OCI part. To me, I think that's not that's probably easy to manage, right? Like it's easy to reuse the tools to fetch or push the artifacts. But technically, I think from performance perspective, is not, to me. I've kind of feel it's not an option. I just like to know. Does anyone do some benchmark? Because the one biggest problem is if you use like OCI and the model weights, so those files are very large, and if you put it into one layer, or even you carefully distributed the layer, I think there's some dominant layers, right? In that case, that's like the bottleneck. And comparing to using like GCS or S3, we can do the like multi-part upload. So the file will be split in very small chunks, and I think that's probably from performance perspective, that's probably the right way to go. Yeah, I just like to do some interview. Anyone test the OCI performance versus the like the S3 pool using like the multiple I enable I think the multi-threads. Yeah.
So pull and push can use multi-part. That's not a problem. Specifically it's the creation of the hash on push that has historically been a problem, and that would probably be the harder one to solve. I guess maybe like we already are going. Most people, I mean, and I could be wrong here. Most people are already going to have a very, very, very large container image. And yes, it's probably 4 or 5 times larger, and it could be up to 10 or 20 or 100 times larger as we go really crazy with weights. But I don't, maybe like if we break the problem into 2, I think there is a cut line, which is if you're optimizing a single model load or a super high scale model load, that's you build that from your primitives, go use object storage, do crazy stuff. But how many of the pulls on Kubernetes clusters over the next 5 years are going to be the base container images, which already have tons of libraries and drivers and compiled code and compute graphs and duplicated libraries? That's actually a place where fixing those also helps. If for instance, model weight parallelization is really a problem, what would it take to get key support for layer parallelization? It might be a little hard. It might not be that hard. Like you could have 4 layers for 4 different files. Like we're already chunking, like Hugging Face already chunks tensor files, right? You could just do 3 layers in a row. Like it doesn't have to be a single layer. So the size limit or the size is somewhat mitigatable. And I guess like to the point, Methosax in the chat, I don't think people think like this. I do because I spent a lot of time doing this like on OpenShift over the years. But an image is just a list of layers, and you can do whatever you want to that. And most runtimes are very forgiving. There's some optimizations that happen on the container D and cryo and other runtime side that would have to be duplicated. But in practice, like the way that you set up the file systems and shared on write, that's all optimizable. It would only take 2 or 3 point improvements to really fix that. So I'm somewhat optimistic, at least, that maybe it's not 1 layer for the model weights, maybe it's 3. That's fine. 10, that's fine. People in the early days of Cube and Docker were generating 100-layer monstrosities with Oracle, and I still don't actually think we're as bad as Oracle was. I don't think models plus all the drivers and libraries today is as bad as Oracle was 10 years ago. So that's at least the room for, I think, that we have for improvement, and it would benefit everybody.
Jeff?
Yeah, so I think one thing I wanted to bring up, like I like the idea of images, right? And I was like really excited about that here at Octo early on, and we, we're looking into these technologies, but none of them were really designed for this use case. Like I brought up Nidus and Dragonfly, but I don't think it was really. That's more designed to make, the images sizes that we were used to, like 1, 2 gigs, like, and distributing those and making those fast. That was what sort of like that work was designed for that, not for 100 gigs of data or that sort of scale. In our case, there's a couple things we've observed. The cloud container registries are slow. Like very slow. Like reading from ECR is like 7 times slower than if I boot up an EC2 instance and stick Docker registry on it, distribution on it, and use an EBS volume in my observations. So that's an element that for the typical cluster user, it would have to be solved. Like if we go this route, like we need high performance from the cloud registries as well. Or a solution for that. Like, what do you deploy on the cluster that maybe adds an extra cache layer between the cluster and the cloud registries? And then again, pushing to those cloud registries, same problem. They're slow. most likely they throttle, I don't know, they throttle IO for noisy neighbor, or however those multi-tenant like registry solutions are implemented in the, I don't know what any of the implementation details there. Lastly, on our use case, which may be an edge case that we don't necessarily need to think about, we have custom checkpoints potentially where people have trained, done full fine tunes on something like Llama 3.1 or whatnot, and we have a whole checkpoint to load. So it's not something that's, I mean, maybe that could be baked into a container image. I'm not saying that that's not the right approach, but in our case, like we may have a pod that's up that for some period of time is serving traffic for one checkpoint, and then may switch checkpoints. So that's an edge case, but we may also be able to solve that with like object store, and maybe the base image is still the most common one, and the weights would be there, but have the
maybe that's a great way of saying it, Jeff, is like the more the use case is geared towards highly common elements, the stronger it is for images, the more that it's bespoke object storage. And I don't think it's a one or the other. I don't know that there's much we can do to improve object storage. Certainly like GKE, AWS, a few others have like object storage file mounts. We leverage that a lot because it's more natural to do file system, and the file system mounts for object storage have improved a lot, especially for read-only use cases in the last few years. It's a big investment area for us, but the container image space, in theory, Cube can make a pretty strong case for. So if we could boil it down to, and I think your point about the cloud registries being slow is a good one, which is how many people think about the performance of the registry, and is it easier to think about the performance of the does a platform team want to think about improving all of the components, or would they just be like, yeah, we'll just go do something with object storage because it has fewer chains there. So I think it's a motivation challenge.
I mean, it seems like the cloud providers selling a premium registry product that provides the performance level for like an additional price point would be attractive to them.
I will relay that to the PMs to tell them that they
GAR plus.
And we notice as well. I mean, I know like some companies are still using P2P pulls, and there's certainly a number of tools in the ecosystem. Those are very, very fast and are mostly orthogonal to all your other choices. So that could be one path that we either.
And
what are the fixed
technologies don't seem to be built for the like 100 gig side, like scope. And there may be like opportunity for that technology separately outside of our scope, maybe to be developed.
Justin?
Yeah, right. I think from like system design perspective, like the container registry or any other like solutions like containerd, they brings a lot of like overheads, right? That's we see like the performance difference between the container registry and S3, and like any S node, I think to the object storage like S3, they have the dedicated like network to the storage. That's why we can hit up to 100 Gbps on some powerful nodes. But on registry, I think talking to the registry, there's no guarantee. I think that's the biggest problem. So if people, I think, like to leverage the highest network throughput, it's better to talk to the object store directly instead of leverage any like solutions. And another thing is I think even like P2P or like local cache helps, but I kind of feel the 0 to 1. I mean, the first time download the model, I think is still blocked on the network side. So we probably can talk about the optimizations in two directions. The first is the 0 to 1 optimization, and the second is the 1 to n optimization. Yeah.
I think this is a conversation worth pushing into the core meeting because yes, it impacts autoscaling and performance, but I feel like this could be a conversation that everyone will benefit from it, right? Like maybe taking the core idea of this conversation to the next week meeting. Now that we've run out of time, right?
Yeah, and we didn't get to model caching, like other forms of model caching either. But like I think since we put a feature in 1.2 or 1.3 or whatever that did this, I think this is a good place to start. But I totally agree. Like we should just take 20-30 minutes and have a list of topics.
Yeah, I mean, like to cache, you need to pull. So this conversation started where you start caching, right? Like pulling the models. So yeah, it was a good conversation anyway. Any last comments, anyone? No? Okay. See you next week, everyone.
Thanks, Gerardo.
Ciao.